We'll write some notes, then we'll continue. Okay, lenses. Next topic, lenses. Next section on new section, lenses. Below, a lens is a transparent. A lens is a transparent refracting medium. Lens is a transparent refracting medium having two surfaces. Two surfaces. Okay, it is a transparent medium having two surfaces. Types of lenses. This is important. Types of lenses. Types of lens. Number one, convex lens. ഇതിനാണ് കോൺവെക്സ് ലെൻസ് എന്ന് പറയുന്നത്. കോൺവെക്സ് ലെൻസ്. Number two, concave lens. Number two, concave lens. Number three, plano-convex lens. Plano-convex lens. The fourth, concavo-convex lens. Concavo-convex lens. Concavo-convex lens. Fifth one, plano-concave lens. Plano-concave lens. Plano-concave lens. Plano-concave lens. Then sixth one, and then opposite, convexo-concave. Convexo-concave. Next, the most similar ആണ്, but ഇത് കോൺകേവോ കോൺവെക്സും ഇത് കോൺവെക്സോ കോൺകേവ് രണ്ട് നെയിമിലും അതിനെ it will mentioned. Next one, optical center. Optical center. Optical center. It is a point on the principal axis. Initially question theory da. It is a point on the principal axis. Maybe lies inside or outside. Maybe lies inside or outside. It's a point on the principal axis. NCERT la adhe definition aanu. It's a point on the principal axis. Maybe lies inside or outside of the lens, through which ray of light undeviated, for which the ray of lenses passes undeviated. So draw the diagram, which means ഇതിൻ്റെ പ്രിൻസിപ്പൽ ആക്സസ്, ഇതിൻ്റെ ഈ സെൻറ്റർ പോയിന്റ്, ഇത് കട്ട് ചെയ്യുമ്പോൾ ഇതിൻ്റെ സെൻറ്റർ പോയിന്റ് ആണ് ഒപ്റ്റിക്കൽ സെൻറ്റർ. ഇത് കൂടെ ഇഫ് എ റേ ഈസ് പാസിംഗ് ദിസ് വിൽ ഗോ അൺഡീവിയേറ്റഡ് ചൊല്ലും. ഈ പോയിന്റ് ആണ് ഒപ്റ്റിക്കൽ സെൻറ്റർ. ഷിഫ്റ്റ് ആവാതെ, സോ ഇറ്റ് വിൽ ജസ്റ്റ് പാസ് എക്സാക്ട്ലി ലൈക്ക് ദിസ്. ഇവിടെ ray pass പണിനാ it is undeviated. അത് ഏത് ലെൻസ് എടുത്താലും അതേ മാതിരി. This is for convex. Similarly, if you draw for a concave lens also, it has an optical center. This point is optical center. This point is called optical center. Optical center. This is called optical center. Irrespective of any lens. This become undeviated. Undeviated passive. This is a rule while we are drawing the ray diagram. If any ray which is passes through optical center, it will directly go. There is no refraction. Okay, refraction is happening here. Refractions will happen here. Refraction, both the refraction actually get cancelled. That's what it is, going in a straight path, undeviated. Finished. Then the next heading, first focus. All this term has to know before we are doing some questions. That's what, initially some theory, then we'll jump into question. First focus. First focus. First focus. This is also called F1. If in question, if you see F1 means first focus, that's the meaning. First focus. Listen, for a convex lens and a principal axis, if an object is at infinity, rays are coming what direction? Parallel. If a ray coming through parallel to the lens, in case of a mirror, where it will intersect? At a focus. So which means this ray will go refraction here, refraction here, refraction here, refraction here, and this will meet at the common point, focus, and this point is called first focus. Okay, so object is at infinity and an image will be formed on the right side. So right side we call it as F1 for the first focus. Okay, meaning called first focus. That's all. So draw the diagram. This is called the first focus, and this is for convex lens. Concave ne vera madri. This is for convex lens. Convex lens is the first focus another. The term there is no significance. Okay, first focus object infinity vechna a rays meet this point, which is called first focus. A convex lens is also called converging lens. Questions in there, converging lens. So convex lens is also called converging lens. In a concave lens always object is at infinity. Concave lens is a diverging lens. So that is the principal axis. Okay, if a ray is coming on meeting here, this will be getting diverges in the sense this is not a mirror, so definitely this will pass over here, this will pass over here, and it will get diverging. This will come here and this will get diverging like this. Concave lens is a diverging lens. Is it corrected to the parallel, little bit tilted like this, then diverging we can project it. So here point if you extend it, it will meet at the principal focus. This is called focus, first focus. So, this refracted ray, sorry, ഇതല്ലേ റിഫ്രാക്റ്റഡ് റേ. റിഫ്രാക്റ്റഡ് റേ എക്സ്റ്റെൻഡ് ചെയ്താൽ വരുന്നത് റിഫ്രാക്റ്റഡ് F1 ഫസ്റ്റ് ഫോക്കസ് ഹിയർ ലെഫ്റ്റ് സൈഡ്. ഇതല്ലേ ഇൻസിഡന്റ് റേ, ഇതല്ലേ റിഫ്രാക്റ്റഡ് റേ. റിഫ്രാക്റ്റഡ് റേ എക്സ്റ്റെൻഡ് ചെയ്യുമ്പോൾ F1 ഫസ്റ്റ് ഫോക്കസ്. Concave lens is also called diverging lens. Diverging lens. This is also called This is called converging lens. This is called diverging lens. ഇനി അതേമാതിരി ഇരിക്കുന്നതാണ് സെക്കൻഡ് ഫോക്കസ്. ഫസ്റ്റ് ഫോക്കസ് മുതല നെക്സ്റ്റ് വൺ റൈറ്റ് സെക്കൻഡ് ഫോക്കസ്. ഒന്നുമില്ല അതിൻ്റെ മീനിങ്, രണ്ട് ഫോക്കസ് ഉണ്ട് ഒരു ലെൻസിന്, അவ்வளோதான். This is called second focus F2. Will never ask, but just for you to remember, there are two focus will be there for a lens. Okay. For a convex lens இதே மாதிரி. Okay, so if a object is placed at optical center, not optical center, at focus, what will happen? After reflections, it will be passes through where? It will be parallel to the principal axis. You start at any point in a second focus. Second focus. You can take in opposite ways also. Okay, first focus or second focus reverse eduthalum that is also correct. Just a theory ana, no required to have questions on. Here also, like this is a principal axis, lines are coming here, lines are coming here. So after refractions passes through these lines will be getting refracted, divergent പോകും. ഇതിനെയാണ് സെക്കൻഡ് ഫോക്കസ് എന്ന് പറയുന്നത് F2. ഇത് കറക്റ്റ് ഇങ്ങനെ ഡൈവേർജിങ് ലെൻസ്, ഇങ്ങനെ ഡൈവേർജിങ്. ഇതിനെ ഇങ്ങനെ മീറ്റ് ചെയ്യിക്കുമ്പോൾ you will meet at some point, and this point is called F2. This is some theory. Okay, no questions will not. Just understand to focus in a simple way.
This side will be
left side only refracted, right? This is the ray which is going diverging ray meeting at this point. F2 this is object is placed.
object will be coming infinity.
ഈ കേസിൽ ഒബ്ജക്റ്റ് ഇൻഫിനിറ്റിയിലല്ല, ഒബ്ജക്റ്റ് ഫോക്കസിലാണ്.
Object should be from infinity, sir, and it will be
here object is at infinity, here object is at focus, here also object is at focus. രണ്ട് കേസിൽ ഫോക്കസ് അല്ല, ഫോക്കസിലാകുമ്പോൾ ഇത് പാരലലും അത് ഡൈവേർജിങ് ലെൻസ്. ദാറ്റ്സ് ഓൾ. ലെറ്റ് മീ മേക്ക് ഇറ്റ് ക്ലിയർ, സിമ്പിൾ. Listen to the board again. Quite simple. Confused. There is no need of confusions here. Listen, one simple way. For example, this is a mirror, right? This is a refracting surface. This is a part of a circle. Now you consider another piece. This is also part of another circle. Correct. So the first circle will have radius R1, for example. Second circle will have diameter is the diameter is D1. Second surface diameter is D2. And corresponding radius of curvature half വരെ ഇരിക്കുന്നതാണ് R1. ഇതിന്റെ corresponding radius of curvature is R2. അപ്പോൾ in short ഒരു കോൺവെക്സ് ലെൻസ് എടുത്തു. കോൺവെക്സ് ലെൻസിന് രണ്ട് സർഫസ് ഉണ്ട്. ലെഫ്റ്റ് ഈ ഫസ്റ്റിൽ ഇരിക്കുന്നത് R1, സെക്കൻഡ് ഇരിക്കുന്നതിന്റെ റേഡിയസ് R2. അതാണ് അതിന്റെ റേഡിയസ്. curvatures of two lenses. Correct. You can say R1 will give rise to one focus f1. R2 will give rise to another focus which is called f2. You can take in a reverse way also. For example, if you are considering this as R2 and this as R2 and this as R1, then R1 is corresponding to f1, R2 is corresponding to f2. Because both are part of a circle. A circle ഒരു portion cut ചെയ്ത glass piece ആണത്. Okay, this is called thin lenses. Normally we call thin lenses. So each will have its own. കാരണം രണ്ട് സർഫസ് ഉണ്ട്. ഈ ഒരു സർഫസിന് this will have its own radius of curvature and its focus. This will have its own radius of curvature and its focus. That's all. Simple way. So two focuses, two radius of curvatures, or we can say two center of curvatures. Understood? Simple way. So then write the next heading. Rules for I'll come.
For concave, this side is f1, and for second time also you wrote f2 this side.
ഇല്ല, അത് ബേസ്ഡ് ഓൺ ദ ഒബ്ജക്റ്റ് പൊസിഷൻ. അതായത് ഇവിടെ ഫസ്റ്റ് ഒബ്ജക്റ്റ് ഇൻഫിനിറ്റിയിലാണ്, റിഫ്രാക്റ്റിംഗ് റേനെ ഇവിടെ മീറ്റ് ചെയ്യിച്ചു. ഓക്കെ, സെക്കൻഡ് കേസിൽ വരുമ്പോൾ ഒബ്ജക്റ്റ് ഈസ് അറ്റ് ഇൻഫിനിറ്റിയാണ്. ബട്ട് ഇതിങ്ങനെയല്ല പോകുന്നത്, ഇത് ഡൈവേർജിങ് അല്ലേ, പാരലലി വന്നിന അതായത് ഫസ്റ്റ് വരുന്നു. കാരണം ഇതിൻ്റെ റിഫ്രാക്റ്റിംഗ് റേ വി കനോട്ട് മീറ്റ്. അപ്പോൾ ഇതൊരു ഇതിവിടെ ചൊല്ലുന്നത് റിയൽ ഫോക്കസ് ആണ്. ഇതും ആക്ച്വലി റിയൽ അല്ല, ബിക്കോസ് ഇറ്റ്സ് എ ഡൈവേർജിങ്. വി കനോട്ട് മീറ്റ് ദിസ് വൺ, കാരണം ആ സൈഡിൽ അത് മീറ്റ് ചെയ്യാതെ. സോ വി ആർ മേക്കിംഗ് ടു മീറ്റ്, ഹി വിൽ ബി ഹിയർ. ഇതിനെയാണ് ഇവിടെ സെക്കൻഡ് ഫോക്കസ് എന്ന് പറയുന്നത്. ഇവിടെ ഈ ഒരു കേസ് കേട്ടാൽ തന്നെ this will never meet here, this will never meet here, refracting surface, which means object is at focus.
So this one correct or wrong?
This is wrong. Where is the diagram in which I have drawn? You draw na? No, nobody draw na. You draw na? You have drawn whatever on the board. Where it is? Where's the first one? Okay, second one.
You have drawn like this.
You
have drawn like this.
Diverging, converging and all. അപ്പോൾ ഈ കേസ് ഇത് ഒബ്ജക്റ്റ് ഇൻഫിനിറ്റി ആണ്, റിഫ്രാക്റ്റിംഗ് റേസിന് മീറ്റ് ചെയ്യിച്ചു, ഫസ്റ്റ് ഫോക്കസ് എന്ന് ചൊല്ലണം. ഇത് കൺഫ്യൂഷനില്ല. ഈ കേസിൽ ഒബ്ജക്റ്റ് ഫോക്കസിലാണ്, ഇത് ഒന്ന് ഡൈവേർജ് ചെയ്തു, റിഫ്രാക്റ്റിംഗ് റേസിന് മീറ്റ് ചെയ്യിച്ചു. ഈ കേസിൽ ഇതിന് F2 എന്ന് ചൊല്ലും. അത് സൈഡല്ല പുറത്ത്. ഇപ്പം നിങ്ങൾക്ക് കാരണം ഇതെന്ന് ചൊല്ലുന്നത് ഇമാജിനറിയാണ്, ദിസ് ഇസ് നോട്ട് ദെയർ. ബട്ട് ഇതിൻ്റെ റിയൽ ഫോക്കസ് എങ്കിരിക്കും, റിയൽ ഫോക്കസ് എടുക്കുന്നത് ഈ സൈഡിലാണ്, ബിക്കോസ് ദിസ് എ പാർട്ട് ഓഫ് ദ ഗ്ലോബ്, ദിസ് ഇസ് എ പാർട്ട് ഓഫ് ദിസ് ഗ്ലോബ്. ഇതിൻ്റെ റിയൽ ഫോക്കസ് ആണിത്, ഇത് വെർച്വൽ ഫോക്കസ് ആണ്. ഈ കേസ് എടുത്താലും ഇത് ഡൈവേർജിങ് ആണ്, ദിസ് വിൽ നെവർ മീറ്റ്. അപ്പോൾ ഇതും ചൊല്ലുന്നത് വെർച്വൽ ഫോക്കസ് ആണ്. ഇതിൻ്റെ റിയൽ ഫോക്കസ് എടുക്കണം എപ്പോഴുമേ ഇങ്ങതാണ്. ഇതെല്ലാം വെർച്വൽ ഫോക്കസ് ആണ്, കാരണം ഒരിക്കലും കൺവേർജ് ചെയ്യില്ല. അതുകൊണ്ടാണ് ഇതിനെ കൺവേർജിങ്, ഇതിനെ ഡൈവേർജിങ്. ദിസ് ഡൈവേർജിങ് പോയിന്റ് വി കനോട്ട് മീറ്റ് എനിവെയർ. അതുകൊണ്ട് ഇതിന് വെർച്വൽ ഫോക്കസ് എന്നാണ് കറക്റ്റ് പേര്. പക്ഷെ ഇതിൻ്റെ ഒരു റിയൽ ഫോക്കസ് ഉണ്ട്. അഫ്കോഴ്സ് ഇറ്റ് ഹാസ് എ റിയൽ ഫോക്കസ്, ദാറ്റ് ഈസ് ഓൾവേസ് ഹിയർ, ബിക്കോസ് ദിസ് എ പാർട്ട് ഓഫ് ദിസ് ഗ്ലോബ്. ഇതിൻ്റെ റിയൽ ഫോക്കസ് ഉണ്ട് ഓൾവേസ് ഹിയർ, ഇതിൻ്റെ റിയൽ ഫോക്കസ് ഉണ്ട് ഓൾവേസ് ഹിയർ, ഇതിൻ്റെ റിയൽ ഫോക്കസ് ഉണ്ട് ഓൾവേസ് ഹിയർ. Next heading, rules for drawing. Rules for drawing. Rules for drawing ray diagram in convex lens. In convex lens. The virtual focus is now will not taken in the reality. It will be only taken the real focus mattum darka. Answer the piece of a globe. Other concept F1 F2 നമ്മൾ diagram panum. First one, ray in convex lens. Number 1, if a ray passes to the principal axis, right? If a ray passes through the principal axis, not if a ray passes parallel to the principal axis, if a ray passes parallel to the principal axis After refraction, it passes through focus. Passes through focus. You can mark F1, F2 anywhere. But ഒരു നോർമൽ സ്ട്രാറ്റജി ബേസ് ചെയ്തിട്ട് ലെഫ്റ്റ് സൈഡിലതെല്ലാം F1, F2 എന്ന് എടുക്കും, റൈറ്റ് സൈഡിലതെല്ലാം അല്ല ലെഫ്റ്റ് സൈഡിൽ F1 എന്ന് എടുക്കും, റൈറ്റ് സൈഡിലതെല്ലാം 2 എന്ന് എടുക്കും. നമ്പർ 1 സൈഡ് 2 സൈഡ് കാര്യത്തിൽ. ഓക്കെ. If a ray passes parallel to the principal axis, ഇതാണ് principal axis. Parallel to principal axis, after refraction it is passes through focus. Number 2. If an incident ray starting from focus, after refraction, it is parallel to the principal focus, principal axis. If an incident ray starting from, means object is at focus. I'll come. If an incident ray starting from focus, which means object is at focus, then after refraction, it is passes parallel to the principal axis. Third one. The ray passes through optical center will become undeviated.
Here we have taken this side as F1, this side as F2.
അതുമായിട്ട് ഡിഫറൻസ് ഇല്ല. ഇതെല്ലാം ലെഫ്റ്റ് സൈഡ് എല്ലാം F1 എടുക്കുന്നു, ആ സൈഡ് എല്ലാം F2 എടുക്കുന്നു, അவ்வளோதான். നോ കണക്ഷൻ വിത്ത് ദാറ്റ്. അത് ജസ്റ്റ് ആ നെയിമിങ് കിടക്കുന്നതുക്ക് മറ്റുംதான். Then number 1, first one, number 1. These are 3 cases we have written, right? Rules for drawing the ray diagram. When a ray is parallel to principal axis, after refraction, it passes through focus. When an object is at F1, after refraction, it is passing parallel to principal axis. If it is going through optical center, it become undeviated. Okay, fine. Then case 1, first case, case 1. Case 1. Object is beyond 2F1. Object is beyond 2F1. Then listen to the careful. So this is the first surface, this is second surface. Everything on the left side marking as 1, second one, everything towards right side is marking as 2. Now this lens in the first curvature, this is a part of a globe as I told. So this will have a center of curvature, this will have a focus also. So if first in the focus F1 mark അതിൻ്റെ ഡബിൾ ആണ് റേഡിയസ് ഓഫ് കർവേച്ചേഴ്സ്, അതിൻ്റെ ഡബിൾ ആണ് റേഡിയസ് ഓഫ് കർവേച്ചർ വിച്ച് ഈസ് റിട്ടൺ ആസ് 2F1 അല്ലേ, ഫോക്കസിൻ്റെ ഡബിൾ ആണ്. റൈറ്റ് സൈഡിലോട്ടും അതേമാതിരി വി ആർ മാർക്കിംഗ് ലൈക്ക് F2, അതിൻ്റെ ഡബിൾ അതിൻ്റെ റേഡിയസ് ഓഫ് കർവേച്ചർ വിച്ച് ഈസ് ഗിവൺ ആസ് 2F2. ഓക്കെ, you can mark like this also, and also you can do like this F2, 2F2, and this can be given as F1, and this can be given as F2, sorry, F1. If one side is taken as 2, another side you can take it as in any other way also, both are correct, but both side vice versa. Okay, next, if I am doing like this one, object is placed beyond 2F1, means here I am considering like 2F1. Okay, and this side becomes, so 2F1, and this become F1, and this become F2, and this become 2F2. Anything you can consider, both sidewise also. The object is placed beyond 2F1 means here I am placing the object. I apply any 2 rules. If an incident ray is parallel to the principal axis, after reflection it passes focus. So this is the focus. So after refraction it is passes through focus. If an incident ray is passes through optical center, it become undeviated. So undeviated like this. This will go straight. So image is formed between F2 and 2F2. അത് ഓപ്പോസിറ്റ് വേണം എടുക്കാം. ഫോർ എക്സാമ്പിൾ, ഇഫ് യു ആർ റൈറ്റിംഗ് ഇഫ് an object is formed beyond 2f2, so we'll get like this one. So image is formed between f1 and 2f1. If I'm changing here, for example, object is placed beyond 2f2, so image is formed between f1 and 2f1. We have to see the size of image. It's a bigger size, smaller size. So it is what type of image? Diminished images, diminished images, inverted images, real or virtual? It's a real image, real image. If we can meet the lines which are going, then we can say it's a real image. It's a real image. Magnifications. Magnification means what? Height of image by height of object. Height of image is smaller, height of object is bigger, and magnification is a negative value. Why? Because height of image by height of object, height of image is negative because it is inverted, height of object is straight, so like this one. Correct? So this is a negative value, but modulus of m is less than 1. Okay, this much point, right? What we have finally written, initially we have written at 2f1, right? So I changed to f1 here, 2f1. You can do anyway, both are correct. So this is f1 because we have written the heading as like that, so I don't want to change it to f2. So to f1, so object is placed beyond, image is formed between f2 and 2f2, diminished in just negative, modem less than 1. Correct, the scale which put another correct varu. Free handle பண்ணும்போது you should have some idea, it should come there. Second case, object at 2f1. Second case. Diminished, inverted, real, magnification, negative. Magnification is height of image by height of object. Image opposite ആണ്, ഇത് straight ആണ്, അത് invert ആണ്, അതുകൊണ്ടാണ് ഈ negative value. ഇതിന്റെ size കമ്മിയാണ്, so it is less than 1. Modulus of m is a negative, and magnitude less than 1 ആയിരിക്കും. And height of image smaller number, height of object is a bigger number. Okay, next. Object is at 2f1. Object is at 2f1. Object is at 2f1. So again we are marking f1 and 2f1. Right side f2 and 2f2. Equal distance mark cheyyanam. So object is here, parallel to the principal axis. After refraction it is passes through where? Focus. Okay, then if a ray passes through optical center, passes through optical center, this will move like this, and image is formed at 2f2 undeviated. So it's a real image, correct. Inverted image, then what else? Same size, m equal to -1, mod m equal to 1. Correct, same size ആണ്. Real image same size. Real image same size. Object first case is beyond 2f. Now it is at 2f1. Next where it will come? Correct. So object between 2f1 and f1. f1 to f1, f2 to f2. Object is here, parallel to principal axis. After reflection passes through focus, optical center meeting at this point. Incident ray, refracted ray, incident ray, refracted ray. So image beyond 2f2. Image is real, inverted, enlarged. Big size, right? Enlarged. Then magnification M is a large negative value. Large negative value. Because it is inverted, bigger size, smaller size. So mod M is greater than 1, bigger size. Fourth one, where it will come? At object at focus at f1. Object at focus. Focus what will happen? Principal axis f1 to f1, f2 to f2. Object is at focus here. Principal axis parallel to the focus. Going through optical center and going. So image is at infinity. Image is at infinity. I can say anyway this side will form, definitely it's a real image and it is an inverted image and it is highly enlarged. Highly enlarged. It's an highly enlarged image. Then magnification M is a very large negative value. Very large negative value. But modulus of M is very much greater than 1. Highly enlarged or highly enlarged is also called magnified. It's also called magnified. Both are same. Magnified, zoomed, enlarged, inverted. Understood? Backside. Highly enlarged. Enlarged means big size. Zoomed. Then the last case, where it will come? Sabri, where it will come? Between focus and optical center. Yes. Fifth. Object between F1 and O. F1 and O. F1 and optical center. F1 to F1. F2 to F2. Optical center, between optical center and focus object is here. Parallel to the principal axis. After refraction passes through focus. And optical center diverging and become undeviated. So it is a diverging line. If you extended these lines, what will happen? This will meet at some point here. This is what type of image? Virtual image. Enlarged image. Erect image, not inverted. Erect image. Then what is the speciality? Magnification. M. Height of image by height of object. M is very much greater than 1 and mod M is also greater than 1. Positive. So convex lens can form enlarged images. Then similar to concave mirror, correct? Concave lens and concave mirror can also form virtual images, real images, real enlarged, real diminished, but virtual enlarged image, concave mirror. If you look into concave mirror, the same pattern will be there, correct? Concave mirror, that's what I told you before coming to the class. Read 1 hour and come, then you can understand whatever I am telling, else you will not understand. Concave mirror, look into concave mirror for a moment. Concave mirror, first class last. Concave mirror. Concave mirror ഉണ്ടായിരിക്കും. Concave mirror first case is what? Object is beyond C. Image is between C and F. This is similar to our first case, right here. Okay. There, object is at C. Image is at where? C. There C is equal to 2F1 or C is equal to 2F2. Both are same. Left side, right side. Okay. There we got what? Same size. Magnification is equal to -1. Mod M is equal to 1. Then what is the third case will be there? Object is between C and F. Images is beyond C. Okay, the same thing will be here also in our case number 3. Their case number 4, object is at focus, image is at infinity. Same thing here, object is at focus, image is at infinity, mod greater than 1. Fifth case is where there? Between focus and pole. But here what is? Here between optical center and focus. Optical center is a common to both pole. And either pole on either pole on. Pole the center on optical center. So between optical center pole, image we got in the same side, right? Like this you got an image will be there also. And this is virtual and this one. Okay. I asked there as couple of questions. M is equal to 0.5 is possible or not in concave mirror? M equal to 0.5 plus means virtual. Possible or not possible? This is also not possible here also. Okay, M positive means positive on this case M positive on M greater than 1. Like M positive value varanadu. Correct? M greater than 1 varanam. M equal to the height of images is smaller than height of object. There are no such cases for a virtual image. But if I am writing like M is equal to +2 is possible here? Yes, possible for this case. Okay, so now I am writing m is equal to minus 2 is possible. Minus 2 means first you look for minus. Minus means inverted. 2 magnitude. So it is inverted enlarged image is possible. Which case it is possible? Object is between f and 2f1. That is possible. Okay, so I'm writing similarly m is equal to, instead of this one, minus 0.5. Is this is possible? Yes. How? Image is a real inverted images, and as well as 0.5. 0.5 is diminished. Which cases will come? Object is beyond C, first case, or in this case beyond 2f1. That's all. Next one. Rules for drawing ray diagram in concave lens. Rules for drawing ray diagram in concave lens. There are certain rules. Number 1. If object is at infinity, if object is at infinity, if object at infinity, image is at focus. Image is at focus. Sign, not a sign convention, or a traditional method madri convex lens draw பண்ணும்போது left side எல்லாம் 1 எடுக்கும், right side எல்லாம் 2 எடுக்கும். Concave ஆமா நேர opposite எடுக்கும். இங்க அதனால ഇവിടെ F2 மார்க் ചെയ്യണം. Suppose we are taking in opposite way in convex, then he also in opposite way. There in convex everything left is taken as F1, everything right is taken as F2. Here reversal എടുക്കും. Just nothing, there is no meaning to written as F1, F2, but that is a meaning. So object is at infinity, image is at focus. Number 1. Number 2, if object is at focus, if object is at focus, if object is at focus, image is infinity. This is a virtual object actually. Object is at focus. Focus is virtual object. And then image is at infinity. Object is at focus. Focus is the focus line. This is not meeting at here, but like this. And image is at focus because it's a diverging lens. Object is at focus, image is at infinity. Image infinity. Third rule. Optical center kuda ray pass pannina, what will happen? It is undeviated. So optical center kuda ray pass pannina undeviated. Focus ku varundana adu diverge cheyum. Parallelly vandanalum adu diverge cheyum. In convex mirror, how many cases we have? While we are drawing the ray diagram, in convex mirror, how many cases? 2. Here also it is 2. So there convex mirror is equal to here concave lens. So what are the 2 cases will be there? First cases is what? Object is between convex mirror. Go and check what we have learned there, the first ray diagram. Infinity and optical center or pole. So here also the same thing. So case 1, object between focus, here in this case F2 and optical center. Left side alarm F2 and optical center. Not F2 and optical center, right? First case is between infinity and optical center, right? Infinity and optical center. First case is there, right? Infinity and pole, infinity and optical center. So here also we'll mark F2. So 2F2, and here it is F1 and it is 2F1. Any point, infinity and suppose if I'm keeping one point will be here. Can you draw the ray diagram using the three rules that we have? Parallel to principal axis. What will happen? Divergent, right? This will go diverging. First rule. So if you extended, this will meet at focus, that you know. That's one rule. Second rule is what? Passes through optical center, it become undeviated. So I passes through optical center and undeviated like this. So these two lines are meeting here, right? So image is where? Between for F2 and optical center. In case of convex mirror, where we got image? Image is between optical center and focus. Same thing will be here also. And it is what type of image? Virtual image. Diminished or bigger size? Diminished. So it is a virtual image. Same thing. Exactly the same thing. Whatever you have learned in mirror, same thing will be here also. But convex mirror, concave lens. Concave mirror, convex lens. Virtual image. Diminished images. Magnification M. It's greater than 0. It's a positive number, right? Height of image by height of object. But I can say 0 greater than M less than 1. Virtual image, and it is between O and F2. O and F2. What is the second case we have learned in convex mirror? Object is at infinity. Same thing will be here also. Convex mirror la enna irukingala adha inga adinte nera copy. Case 2. Object at infinity. Object at infinity. Object at infinity. So parallel rays divergent. Parallel rays divergent. If you are meeting this line, it will meet at where you got a image will be there. In case of a convex mirror, focus. Okay. So image at F2 highly diminished. Highly diminished. Highly diminished. Magnification highly diminished and also lost in the same side. So it's a virtual image. It's a virtual image. We can say like this is a highly diminished, also called point image. Magnification M greater than 0, but 0 greater than M less than 1. Anyway, it's a positive number. But it's a very small number, 0.1. அதே மாதிரி இல்லை இங்கே இருக்கும்போது ஒரு 0.2, 0.5 கொஞ்சம் கூட பெருசாக இங்கே பயங்கர ஸ்மால், வெரி ஸ்மாலாக இருக்கு. Just to draw a tabular column, what we have done, same way for mirror. കോൺവെക്സ് ലെൻസ്, ഒരു കമ്പാരിസൺ സ്റ്റഡി. കോൺവെക്സ് ലെൻസ്, ഓക്കെ. കോൺകേവ് ലെൻസ്, കോൺകേവ് ലെൻസ്. ഇവിടെ കീഴെ എഴുതണം കോൺവെക്സ് ലെൻസ് ഈക്വൽ ടു ഇരിക്കണം. കോൺകേവ് ലെൻസ് ഈസ് ഈക്വൽ ടു കോൺവെക്സ് മിറർ. ഇതിന്റെ കണ്ടീഷൻസ് എല്ലാം സെയിം ആണ്. ഈക്വൽ ടു എഴുതണത് ലെൻസ് ഈക്വൽ, ലെൻസ് ഈസ് നോട്ട് ഈക്വൽ ടു മിറർ ഓഫ് കോഴ്സ്, ബട്ട് ഫോർമുല വൈസ് അല്ലെങ്കിൽ അതിന്റെ കോൺസെപ്റ്റ് വൈസ് രണ്ടുമേ ഈക്വൽ ആണ്. You cannot write something like this in the board examination paper, right? Okay. So what all the type of images can be formed? Real and virtual image can form, right? Real and virtual image can form. Here only what type of image? Only virtual image. Only virtual image. Real enlarged image. Real enlarged image possible, or real diminished image possible. Diminished image possible, or virtual enlarged image. Only these things are possible. Correct alla? Real enlarged, real diminished, virtual enlarged. Other side what all things are possible? Virtual diminished. Virtual diminished. Virtual diminished. Where speciality? M equal to -1 or mod m equal to 1 possible. Correct alla? This side is not possible. നോർമലി സ്കൂളിൽ പഠിക്കുമ്പോൾ ഇപ്പോഴും തന്നെ ഈ ടേബിളർ കോളത്തിൻ്റെ കമ്പാരിസൺ പഠിക്കണത് ഒരു സൈഡ് മട്ടും പഠിച്ചു, നേരെ സൈഡ് ഓപ്പോസിറ്റ് ടക്ക് കേട്ടോ. എല്ലാത്തും കൂടെ നോട്ട് ഉണ്ടാവേണ്ടത് ഇത് ആ സൈഡായി. റിയൽ ഒരു അതിങ്ങനെ കൗണ്ട് കേട്ടിനാ അത് അതേ മഴ ഉണ്ടോ. ഓക്കെ, next write the stuff again. Lens makers formula. Lens makers formula. Lens makers formula. Again idukku triangle eduthe similar triangle concept eduthe derivation steps will be there. I am not going there. 1 by f is equal to 1 by f is equal to nl divided by nm minus 1 into 1 by r1 minus 1 by r2. nl is the refractive index of the lens. nm is the refractive index of the ri of the medium. Refractive index of the medium. Refractive index of the lens. R1 is the radius of curvature of the first surface. R2 is the radius of curvature of the second surface. അതായത് ഈ ഒരു ലെൻസിന് രണ്ട് റേഡിയസ് ഓഫ് കർവേച്ചേഴ്സ് ഉണ്ടായിരിക്കും, രണ്ട് ഫോക്കസ് ഉണ്ടായിരിക്കും. but the combined focal length will give by lens maker's formula. Okay, lens maker's formula will give a combined, because this will have its own focus, this will have its own focus, this will have its own radius of curvature, this will have its own radius of curvature. Combine the effect on a small f. Normally f so far we have written capital F. Capital F is the individual lens piece in the focus on. Small f is the combined focal length. Always remember that. Okay, small f and capital F is small f on. Small f is a combined effect on. F1 F2 is a piece in the effect on. Okay, we'll do questions and we'll see. Okay, write down the question problem. A biconvex lens, normal convex lens first one. A biconvex lens has R1 equal to R2 equal to 10 centimeter. And refractive index of the lens is 3/2. Find the focal length of the lens in air. A convex lens has R1 equal to R2 is equal to 10 centimeter and refractive index of the lens is 3/2. Find the focal length of the lens in air. We have to calculate the focal length of the lens in air. So it's a biconvex lens, right? Biconvex means like this, convex lens. Okay, so by sign convention we'll always assume incident ray is from left side. So here two radius of curvatures will be there. R1 will be there, R2 will be there. Lens maker's formula NL, refractive index of lens equal to 3/2. Refractive index of the medium air is equal to 1. R1 is in the direction, R1 is measuring like this one, right? So R1 is what sign? R1 equal to plus 10 centimeter. R2 is this one, this is measuring like this, R2. So R2 is equal to minus 10 centimeter. Substitute, you will get the value. What 10? Plus 10. Substitute the values will be there, that equation, sir, so that you will get the answers. 1/f equal to 3/2 divided by 1 minus 1. 1 by R1. R1 is positive. 10 minus 1 by minus 10. So 3/2 minus 1. 1.5 minus 1. 0.5. 1/2 into 2/10. 2 cancel. So 1/f is equal to 1/10, which means f is equal to 10 centimeters. Next question. Find the focal length of the arrangement shown in the figure. Find the focal length of the arrangement. Find the focal length of the arrangement shown in the figure. One second. Find the focal length of the arrangement shown in the figure. Find the focal length of the arrangement shown in the figure. a formula, the same formula will apply. NL equal to length into the NL means refractive index 3 by 2. N medium is 1. R1 is plus 20 minus 20 plus 20 because the first surface is R1, so it is towards right. R1 equal to plus 20. R2 infinity because it's a plane surface, so here R1 equal to plus 20, direction right side, right? And this is R2, plane surface. Plane surface is infinity. There is no radius of curvature for a plane surface. Only for a curved surface will have radius of curvature. Plane surface no radius. Radius is infinity. Maths fundamental. What's answer? 40. Plus 40 or minus 40? Plus 40 centimeters. R1 R2 എടുക്കുന്നത് ചേഞ്ച് ആക്കൂടാ. Next question. A convexo-concave diverging lens has refractive index 1.5 and focal length 24 centimeter. Focal length is given when it is kept in air. If the radius of the first surface is double the other surface, find the radius of the surface. A convexo-concave diverging lens has refractive index 1.5. The focal length is 24 centimeter when in air. If the radius the first surface is double the other, find the radius surface. They have given one diagram also. Additionally, I know everybody is drawing the book to get the diagram. This is incident ray, this is R and this is 2R. Doubt?
Convex concave எப்படி தான் சார்? Convex
எവിടെ types of lens எங்க?
அது கான்வெக்ஸ்னா இந்த சர்ஃபேஸ், கான்கேவ்க்கு இந்த சர்ஃபேஸ்.
இது ரெண்டுமே ஒரே மாதிரி தான். கான்கேவோ கான்வெக்ஸ் இது மாதிரி இல்லைல்ல நான் ட்ரா பண்ணது.
அது வேறு அந்த மாதிரி இருந்துச்சு சார்.
ഇത് மாதிரி தான், ரெண்டும் இது மாதிரி தான் இருக்கும். കാരണം ഇത് രണ്ട് വയസ്സും ഇത് സെയിം താ. കോൺകേവോ കോൺവെക്സും കോൺവെക്സോ കോൺകേവ് സെയിം താ. ബട്ട് അതിൻ്റെ എഫക്റ്റ് എന്നാ കേട്ടിനാ കോൺവെക്സോ കോൺകേവ് എന്ന് പറയുമ്പോൾ ടോട്ടൽ എഫക്റ്റ് ലെൻസിൻ്റെ വരുന്ന എഫക്റ്റ് റേ കൊടുത്തിന് അത് കൺവേർജിങ് എഫക്റ്റ് ആയിരിക്കും. അതുകൊണ്ടാണ് കോൺവെക്സോ ഫസ്റ്റ് ഇതിന്. ഇതിന് ടോട്ടൽ എഫക്റ്റ് ഡൈവേർജിങ് ആയിരിക്കും. സെയിം ഡയഗ്രാം തന്നെ ഓൾമോസ്റ്റ് രണ്ടുമേ സെയിം തന്നെ. நம்ம நோட்டில் டயக்ராம் ட்ரா பண்ணதை எப்படி எனக்கு தெரியாது. മറ്റത് കോൺകേവ് കോൺവെക്സിൻ്റെ മോസ്റ്റ് സിമിലർ ആയിരിക്കും. ഇങ്ങനെ അത് ഇവിടെ ഒരു കട്ട് ഉണ്ടാവുള്ളൂ, വേറെ ഡിഫറൻസ് ഒന്നുമില്ല. എഫക്റ്റ് വൈസ് സെയിം ആയിരിക്കും. കോൺവെക്സോ ഇമ്പോർട്ടൻസ് കൊടുക്കുന്നത് കൺവേർജിങ് നേച്ചർ ആയിരിക്കും, മറ്റേ ഡൈവേർജിങ് നേച്ചർ ആയിരിക്കും. അതാണ് minus 6 centimeters. Got it? சொல்லுங்க விமல், NL how much? 3 by 2. N medium 1. R1 R1 minus R. R1 means first surface. R2 means this one. Simple. Okay. R2 is how much? On the E side lotal edukkunnathu. This also. So R2 is also equal to minus 2R. There is no confusion, nothing. This is part of a circle. This is a part of another circle. So both are towards left side. Instant ray is in this direction. Both are opposite. So R1 is minus R. R2 is minus 2R. So answer is minus 6, huh? Minus 6, okay. So all these things will be there. We'll substitute in the formula, Lenz's formula. 1 by F is equal to NL divided by NM minus 1 into 1 by R1 minus 1 by R2. Substitute there, you will get the value of focus equal to minus 6, huh? Radius they are asking. So what you are getting focus? Focus they have given. They are asking the radius of curvature. So double the focus. How much? Not double the focus. Like capital R there. This R they are asking, right? R you substitute 2R. F is given 24. Okay. So F is also given here 24 centimeter. Capital R is how much? Minus 6 centimeters. Okay, done. Correct. Next question. All of you got the answer. F is given 24, NL 3 by 2, NM air, R1, R2 is given. We have to find out the R. Next question, important. Focal length. What is the question? Which question I told them? I forgot. Convex or concave diverging lens. Negative. Correct. This is negative, right? Focus is negative, not positive. Focus negative alla. Convex or concave. Focus negative. Focus negative edukka. Ee rendu lens eduthalum ayine focus varunathu left lota. Okay. In a simple way you can remember like this. Convex. If a convex lens you have done some question, right? You have done some question. What is the focus you got for convex lens? Positive or negative? Positive, right? Plus value you got. So for convex F is positive. Concave F is negative. This convex nature ആണ്. ഇത് പ്ലാനോ വിട്ടുന്നത് convex nature ആണ്. ഇതൊക്കെ concave nature ആണ്. So F is equal to minus 24 എടുത്തന. What is the value coming? Same. Both case same. Tell me answer. R equal to minus 6 plus 6. Minus 6. Okay. I didn't run. I written like that. Let me see what answers I got. R, but I got R equal to plus 6 ആണല്ലോ. Plus 6 ആണ്. ചുമ്മാ minus 6 എന്ന് சொல்லி. ഈ വാല്യൂ കാൽക്കുലേറ്റ് ചെയ്യുമ്പോൾ R എന്താ? അത് ഫ്രം ദ ഒപ്റ്റിക്കൽ സെന്ററിൽ മെഷർ ചെയ്യുന്നത്. വി the sign conventions here. Why you want to again apply sign convention? R equal to minus R, sign convention applied. R equal to minus 2R, you already applied sign convention. If you again apply means your answer will be changes.
But she got the answer plus 6.
Plus 6 means 6. No. I applied sign convention. Already R1 equal to minus R, R2 is equal to minus 2R means you already given to the answer state that I am taking left side, you already given. Then you are saying left side it is plus 6. Okay, now if you say minus 6 means you are again saying left side it is minus 6. No, left side plus 6 means right side minus 6 and so on.
So initially we didn't take the side means it will come as minus 6.
Initially അതായത് ഇത് ഫോർമുലയാണ്. ഫോർമുലയിൽ വാല്യൂ സബ്സ്റ്റിറ്റ്യൂട്ട് பண்ணும்போது സൈൻ കൺവെൻഷൻ സ്പോട്ട് എടുത്താൽ വാല്യൂ സബ്സ്റ്റിറ്റ്യൂട്ട് பண்ணണം. R1 നെഗറ്റീവ്, R2 നെഗറ്റീവ്, F നെഗറ്റീവ് ബിക്കോസ് കോൺകേവ് നേച്ചർ. വര ആൻസറിനോ അതാണ് ആൻസർ. അതിൽ പിന്നെ പിന്നെ സൈൻ കൺവെൻഷൻസ് നോക്കുക. സൈൻ കൺവെൻഷൻസ് ഇനീഷ്യലി പോട്ടാൽ മുടിஞ்ச അവിടെതാണ്. ക്ലിയറാ? ഇപ്പൊ അവർ കേട്ടൊരു ക്വസ്റ്റ്യന് I got R equal to plus 6 and solina. This is the value which is coming after calculation. But she is asking R is towards left side. So R is again minus, right? No, correct. While applying to the formula, always remember, formula is a formula only. Okay, you cannot change this one. So whatever the values which are given to you, you have to apply the sign convention. Here I taken R1 equal to minus 6, R2 is equal to minus 2R because both are left side. Focus is minus 24 because it is a concave nature. Convex or concave, this is concave nature. Concave, both surface concave nature. That's F negative. Value substitute whatever you are getting, the plus 6, here 6 indicate 6 centimeter towards left side. You are not again apply minus. No, if you apply again minus, if you are saying me answer minus 6, then I am assuming minus 6 centimeter towards left side, which means 6 centimeter towards right side. That's concept. It is plus 6 centimeter means plus 6 centimeter towards left. So you are not supposed to apply sign convention again after you are getting answer. No, only you are apply these signs before you are putting the values into the equation. Okay, write the next question. A convex lens of refractive index. A convex lens of refractive index. Convex positive, concave negative. Keep it in mind. Convex lens of refractive index 1.5 and has a focal length 20 centimeter when kept it in air. When kept it in air. Find the focal length and the nature of lens when it is kept in a liquid of refractive index 2. This question is important. Find the focal length and the nature of the same lens when kept it in liquid of refractive index 2. Number 2. I'll repeat the question. A convex lens of refractive index 1.5 have the focal length 20 centimeter when kept it in air. Find the focal length and the nature of the same lens when kept it in a liquid of refractive index 2. No, never. How it is remain same?
Property of the lens.
Yeah, but property of the lens is depends upon what? F is depends upon what? NL. F is depends upon what? NM. But if the same setup is immersed in a liquid, R1 and R2 will not change us. But this focus is depends upon medium.
Same mirror
mirror vechi kettina mirror ആ മിററിൽ നിങ്ങൾ പഠിക്കണത് 1/v minus 1/u. വേറെ എന്നാ ആളുതാ. പിന്നെ മിറർ will have any formula which is connecting with the refractive index. Any formula you have learned? No, I didn't remember any formula. Then it is constant. If it is connected with the refractive index through any formula, then definitely its nature will be changed.
This is convex, so concave.
ഇതിന് ഷേപ്പ് ഉണ്ട്. ഓക്കെ, ഇതാണ് കോൺവെക്സോ കോൺകേവ്, ഇതാണ് കോൺകേവോ കോൺവെക്സ്. രണ്ടും സിമിലർ ഷേപ്പാണ്, കറക്റ്റ് അല്ലേ? ഇതിനെ കോൺവെക്സോ കോൺകേവ് ചൊല്ലാൻ കാരണം ഇതിന് ഡൈവേർജിങ് നേച്ചറാണ്. ഇതിന് കോൺകേവോ കോൺകേവ് ചൊല്ലാൻ കാരണം കൺവേർജിങ് നേച്ചറാണ്. അவ்வளோதான். അപ്പോൾ ഇതിന് ഡൈവേർജിങ് നേച്ചർ ആയതുകൊണ്ടാണ് ഇത് കോൺകേവ് ലെൻസിൻ്റെ പ്രോപ്പർട്ടിയാണ് ഇതിൻ്റെ ഫൈനൽ റിസൾട്ട്. അതുകൊണ്ട് ഇതിന് ഫോക്കൽ ലെങ്ത് നെഗറ്റീവ് ആയിരിക്കും, ഇതിന് ഫോക്കൽ ലെങ്ത് പോസിറ്റീവ് ആയിരിക്കും. ഇതെന്നാ പ്ലാനോ കോൺ, അപ്പോൾ പ്ലാനോ വിട്ടിനാ കോൺകേവ് தான். അപ്പോൾ കോൺകേവ് വരുമ്പോൾ നെഗറ്റീവ് ആയിരിക്കും. ഇത് പ്ലാനോ കോൺവെക്സ്, പ്ലെയിൻ വിട്ടിനാ കോൺവെക്സ് പോസിറ്റീവ് ആയിരിക്കും, നെഗറ്റീവ് ആയിരിക്കും, പോസിറ്റീവ് ആയിരിക്കും.
இந்த பக்கம் இப்போ மிரர்லாம் நம்ம எழுதும்போது கடைசியாக நம்ம வந்து அந்த சைன் கன்வென்ஷன் வச்சு நம்ம சேஞ்ச் பண்ணி
சைன் கன்வென்ஷன் வச்சு நம்ம ஃபார்முலையில் வேல்யூ இட்டுரும். இட்டதுக்கப்புறம் ஆன்சர் கிடச்சுன்னா ஆன்சரில் சைன் கன்வென்ஷன் தூக்கக்கூடாது. ஃபஸ்ட்டு ஃபார்முலா அப்ளை பண்ணும்போது யூ ஆல்ரெடி டேக்கன் R1 negative, R2 negative, F negative, already you have written here. Then you got answer as 6. 6 means 6 centimeter from left side, that's all. You are not supposed to apply again sign conventions to the final answer. No, you already applied, you got it. Then if you are again applying means you are reverting whatever you are doing. That is not allowed.
not applying, yes sir, but if I'm marking in the diagram,
Marking in the diagram towards left side.
towards the side.
Left side, from the center, optical center towards left side is 6 centimeter away.
This is negative.
Yes. It is not negative, it is towards. See, you got plus 6. How you got plus 6? Because you already told I am taking towards left. I am taking towards left. Then you say towards left 6 minus towards left 6. You already informed this one. Hey, I am taking R1 left, R2 taking left. I am getting 6, so which means 6 left.
So it's accepting my sign convention, so it's coming as yes. The sign convention is accepted by the answer.
Yes. Doubt? Minus 15. We'll solve it. Okay. Can you just help me with the values? What are the values we have given? It's a convex lens. Focal length plus 20. So plus 20. Of course, convex 20 centimeter. What else, somebody? Refractive index. NL equal to how much? 3/2. First it is in air medium. Okay, so let me apply the formula. 1 divided by F is equal to NL divided by NM minus 1 into 1 by R1 minus 1 by R2. I'll come. 1 by F. Okay, so value we are substituting 1 by 20 is equal to NL 3/2 divided by 1 minus 1. I am not bothering about this right side parameter. I am just keeping the formula as such, because when immersing in a liquid R1 R2 nobody is going to change. Okay, so I don't want to bother about what is there in the right side. It doesn't matter. This is for air, equation number 1. Next, for a liquid, if you are immersing in a liquid, for length you don't know, I am taking as 1 by F dash. Okay, and this is 3/2, but medium is now a liquid, so it become 2 minus 1. Right side anyway, which will not changes if it is liquid, if it is in air or if it is in a liquid. Equation number 1 divided by equation number 2. I want to find out F dash, right? So, which is equal to 1 by 20 divided by 1 by F dash is equal to numerator 3 by 2 minus 1, 1.5 minus 1, 0.5. 0.5 means 1 by 2 divided by, but 3 by 2, 3 by 4 minus 1 in the denominator, 3 by 4 minus 1. Now I have to solve this one. This means f dash divided by 20 is equal to 1 by 2, 3 by 4 minus 1, minus 1 by 4. Okay, so f dash divided by 20 is equal to minus 4 by 2. F dash is equal to minus 40 centimeter, which means that what? A convex lens. Okay, what is the interpretation from here? Listen very carefully. Come. Initially, this is a hint to answer in a 10 seconds. So this is a convex lens having focal length plus 20 centimeter. Okay, but it is here, it is air. Refractive index 1, refractive index 3 by 2. Now what you done? This is dipped in a liquid. If you are dipped in a liquid, it is still, it is like this, but instead of air, now your refractive index is 2. Here refractive index is what? 3 by 2. Okay, now you remember this refractive index of lens is greater than air. Okay, nature of lens is convex. Now if you dip it in a solution, the refractive index of the lens is less than the refractive index of the medium. Lens convex now become concave lens. Concave lens, which means 40, because you got negative means for a concave lens. So if the outside medium will have a refractive index higher than inside medium, even though if it is a convex lens, outside medium refractive index higher than inside refractive index, then convex lens will behave as concave lens and vice versa. Similarly, your concave lens, if it is a concave lens, it will behave as a convex lens. So write a note. Write a note. If a convex lens is dipped in a solution, if a convex lens dipped in a solution having refractive index higher than the lens, having refractive index high, this is a very important point, it's higher than the lens, then in the solution it behaves as a concave lens. It behaves as a concave lens. Okay, and vice versa, opposite also. Concave ne dip edalla convex ayi marum. So this, the problem what we have done, the last is very important. Next heading, lens formula. Of course, one by v plus 1 by u equal to 1 by f. Lens ke minus varu. 1 by v minus 1 by u, 1 by v minus 1 by u equal to 1 by f. Okay, so if you have space on your notebook, you can just classify it like this: mirror. 1 by f equal to 1 by v plus 1 by u. This is a one thing. Okay, in case if you know. One more parameter, magnification. Here it is v by u, which is equal to height of image by height of object. There it is, magnification m equal to minus v by u is equal to height of image by height of object. Compare it and study, like how you studied gravitation, electrostatics. Then write a question. Find the position and the nature of image. Find the position and the nature of image of the system shown in the figure. Whether it's a real image or virtual image, you have to say. Do it. Then you used it again. Midden doing. Come on. Correct da. Simplify. Evalo? 20 plus 20 yeah? How you say it's real image? Okay. Another way to know that, yesterday I given a clue, right? If u and v are the same sign, then it is a real image. That's the easy way to understand. U and v are the opposite sign, then it is a real image. Yesterday we have written one note. Okay, you can also write if you don't know. If u and v have the same sign, u and v name have the same sign, then it is virtual image. If u and v opposite sign, then it's a real image. That mirror opposite ആണ്, lens opposite ആണ്. U and v opposite sign, u and v opposite sign ആയിരുന്ന real image. Here in this case your u is negative, but you got v is positive, so it's a real image. And if both are same sign, then it's a virtual image. So answer here it is v is equal to 20 centimeters plus 20 in the. If you substituted 1 by f, f is positive, correct? 1 by f equal to 1 by v minus 1 by u. F in the value plus 10, v arilla, u in the value minus 20. Substitute you will get v equal to plus 20 centimeter. Now Shapiri, answer to your question. Now I got 20 centimeter, right? 20 centimeter is, which side will come? Right or left? Right side, 20 centimeter. So this means this is from where? From the optical center. Optical center. But here we are not applying up left alum, right alum. Here we are not applying any sign conventions. These sign conventions will apply once we are substituting the values only. Okay, after answer not substitute any sign conventions. Next one, next question. A concave lens of focal length 10 centimeter. A concave lens of focal length 10 centimeter in air has an object 5 centimeter in front of it. Find the position and of image. Find the position and nature of image. Find the position and nature of image. What's the value? Minus 3.3 centimeter. So u in the sign negative ana, v in the side negative ana. So both is a virtual image because it's a concave lens. Concave lens will form a virtual image, no real images also. That substitution, right? In this question, what are the values which are given there? F equal to minus 10, U equal to minus 5. So 1 by V, F is equal to 1 by V minus 1 by U. Substitute the values over here, you will get V is equal to minus 3.3 centimeter. So both are U and V, same sign. So it's same sign. So it's a virtual image. It's virtual images. Next question. In the system shown in the figure, refractive index of the thin lens is 1.5. In the system shown in the figure, refractive index of the thin lens is 1.5 and it's kept in a liquid of refractive index 2. And it is kept in a liquid of refractive index 2. Find the focal length. Find the focal length, position and nature of image. Position and nature of image. Find the focal length. Focal length is the first part. Second part, nature of the image. Your lens structure is given. R equal to 20 centimeter left side, 40 centimeter liquid object at 60 centimeters away. Focal length കണ്ടുപിടിക്കാം. Then അതുക്കപ്പുറം രണ്ട് ഫോർമുല യൂസ് ചെയ്യണം. 1 by f is equal to nl divided by nm minus 1 into 1 by r1 minus 1 by r2. From that one you have to find out what? F കണ്ടുപിടിക്കണം. ആ f യൂസ് ചെയ്തിട്ട് f is already there, u is already given. You have to find out v. The nature of image also you have to tell. So it's a two-step process. First f കണ്ടുപിടിക്കണം, പിന്നെ അതുക്കപ്പുറം v കണ്ടുപിടിക്കണം. So two steps. R1 value how much? R1 plus 20 minus 20 plus 20. R2 plus 40. Then substitute and then first tell me what you get for focal length. Minus 160. Okay. I don't know. Minus 160, Praveen. Okay. Then, if you got f is equal to minus 160, I don't know. Whatever you got it, then substitute for u and f and find the value of v and tell me the nature of image. Calculation mistakes varuthakoodadu. Okay, be careful because fraction numbers allow. Most of the time we are dealing with the fraction numbers. അതുകൊണ്ടാണ് ചിന്ന ക്ലാസ്സിൽ നല്ല സൂപ്പറാக പഠിക്കണം എന്ന് ചൊല്ലണം. I heard like all the 11th students are all passed in Tamil Nadu. Correct? Super. Amazing decision. 960 by 22. അത് പോതും. വേണ്ട ഒരു സ്റ്റെപ്പ് കൊണ്ട് ചിന്നതാക്കാം. 480 by 11. അவ்வளோதான். Position V. Fraction சொல்லுங்க. 480. Minus 480 by 11 480 by 11 means approximately 48 வேண்டாம் by 10 எடுத்துனா இல்லைன்னா minus 480 by 11 fraction is enough. 480 minus 480 by 11 which means towards left side minus 480 by 11. Okay. Okay, both are correct. ஷர்ட்டெல்லாம் கெத்தாக இருக்கு. சொல்லுங்க.
This is concave. See, concave or convex, sir.
இதுக்கு கான்கேவா கான்வெக்ஸ் இல்லை கான்வெக்ஸா கான்கேவ்னு சொல்றோம். எப்படி இருந்தாலும் ஓகே.
F equal to minus 160. This is in liquid medium, sir. So this is greater than this one, sir. So it will act as concave. So for concave, focal length is negative, sir. So focal length negative na minus of.
இல்ல அது நீங்க you already got a minus.
Sir.
மைனஸுக்கு பின்ன திருப்பி மைனஸ் அப்ளை பண்ணக்கூடாது. ஆல்ரெடி நீங்கள் இங்கே சைன் கன்வென்ஷன் எல்லாம் கொடுத்துருக்கேன். R1க்கு R2க்கு எல்லாம் கொடுத்துருக்கேன். கொடுத்ததுக்கு அப்புறம் தான் வேல்யூ கிடச்சிருக்கு. அந்த வேல்யூக்கு பின்னே தூக்கி சைன் கன்வென்ஷன் போகக்கூடாது.
So but for focal length we didn't apply a sign convention. For this one you applied, sir. So for second case it is liquid medium, sir. So for focal length now only we are applying.
இல்லை ஃபர்ஸ்ட் கேஸில் லிக்விட் மீடியம் தான். ஃபர்ஸ்ட் கேஸில் ஆறு லிக்விட் மீடியம் இல்லைன்னு சொல்லி ஃபர்ஸ்ட் கேஸில் நீங்கள் லிக்விட் 3/4 கொடுத்துருங்களா? ஃபர்ஸ்ட் கேஸில் லிக்விட் தான். நீங்கள் ஃபோக்கஸ் கால்குலேட் பண்ணும்போது லிக்விட் தான். இமேஜ் கால்குலேட் பண்ணும்போது லிக்விட் தான்.
But first case we didn't apply for focal length, sir. So we didn't apply means second case we are applying.
ஃபர்ஸ்ட் கேஸில் அப்ளை பண்ண ஃபர்ஸ்ட் கேஸில் ஃபோக்கல் வந்து கண்டுபிடிச்சு.
Yes, sir. So after applying we got 1/60, sir.
After applying,
sir, first இதுக்கு minus 160 கிடைச்சு. ஸோ இப்போ இதுக்கு வந்து நம்ம அப்ளை பண்ணல சார் ஃபர்ஸ்ட் கேஸ். ஸோ செகண்ட் கேஸ் வரும்போது நம்ம வந்து லிக்விட் மீடியம் இருக்கிறதுனால வெக்ஸ் வந்து
அதான் இதில் நீங்கள் இங்கே NL by NM நீங்கள் எடுத்தப்போ 3/2/2 எடுத்தோம். யூ ஆல்ரெடி அப்ளைடு மீடியம் ஹியர்.
Yes, sir.
You already applied the effect of medium effect you already applied here. If you applied the effect of medium here, you got f is equal to minus 160. You don't want to apply again one more plus 60. No. You applied here, you got it. ഈ கிடைச்ச வேல்யூக்கு பின்ன ஒரு சைன் கன்வென்ஷன் அப்ளை பண்ணக்கூடாது. அது அப்படி இருந்தால் அதே மாதிரி இருக்கணும். அடுத்த ஸ்டெப்பில் ஃபர்ஸ்ட் ஸ்டார்ட் டைம்னால சைன் கன்வென்ஷன் கொடுக்குறேன். அதோட இந்த ஸ்டெப்பு முடிச்சு. So what you got? F is equal to minus 480 by 11. Correct? In this steps, first we have to find out the focal length. Like just explain. R1 equal to plus 20, R2 equal to plus 40, NL equal to 3/2, NM equal to 2. We'll apply the formula 1 by F is equal to NL divided by NM minus 1 into 1 by R1 minus 1 by R2. You got it as focus is how much? Minus 160 centimeter. Then next step 1 by F is equal to 1 by V minus 1 by U. Here U equal to minus 60 centimeter. Apply. Then find the value of answers. Next question. Find the position, find the positions, comma, size and nature of image. Find the position, size and nature of image formed by a convex lens of focal length. Find the position, size and nature of image formed by a convex lens of focal length. 10 centimeter of focal length, 10 centimeter, when an object of 2 centimeter long is kept in front of it, at a distance of 15 centimeters, at a distance of 15 centimeter, at a distance of 15 centimeter. Here the size of the object is given, HO is given 2 centimeter. Okay, so you have to find out the position of image, size of the image, nature of the image. Position അത് എങ്ങനെ എടുക്കും? Size means HI കണ്ടുപിടിക്കണം. Okay, the next one, nature, virtual ആണോ inverter ആണോ, what is the type? Whether it's a real or it's virtual, that things. How much is the value of V? 30 plus 30 minus 30 plus 30. Height of image minus 4 means what? Inverted. So it's a inverted. U and V in the same opposite. So it is what type of image? So it's a real inverted image and enlarged. Size adhigalla to become 4. So it's a real inverted enlarged image. HI equal to minus 4. Minus indicates it's an inverted image. Size is 4. Okay. R1 left ഉള്ളത്, R2 റൈറ്റ് ഉള്ളത്. എപ്പോഴുമേ ലെഫ്റ്റ് R1. ഇതിൽ ഇത് R1 ഇത് R2. എപ്പോഴുമേ ലെഫ്റ്റ് R1 റൈറ്റ് R2. ഫസ്റ്റ് ടു സെക്കൻഡ്. നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ. റൈറ്റ്. നെക്സ്റ്റ് വൺ. A convex lens has a focal length 12 centimeter. A convex lens has a focal length 12 centimeter. How far the object from the lens is placed? How far the object from the lens is placed so that image formed is virtual and 3 times the size of the object. So that the image formed is 3 virtual and 3 times the size of the object. virtual image ன்னு சொல்லும்போது magnification value positive or negative? Magnification positive. Virtual image ആണ് height of image straight ആയിരിക്കും, height of object straight ആയിരിക്കും. അപ്പോൾ രണ്ടുമേ വരുമ്പോൾ പോസിറ്റീവ്. സോ m equal to +3 എന്ന് എടുക്കണം. അതാണ് എൻ്റെ ക്ലൂ. കറക്റ്റ് അല്ലേ? m equal to +3. Then what else will be there? Object distance കണ്ടുപിടിക്കണം. U has to find out. Focal length f is given +12 centimeter. Then balance is with you. So m equal to v by u equal to +3. F is given 12 centimeter. U has to calculate. Vimal, how much is answer? Evlo? Minus? Minus.
So write the next heading. Combination of thin lenses. Combination of thin lenses. Combination of thin lenses. Combination of the lenses means if you have one lens, it's connected with the next lens. Multiple lenses, combination lenses. Okay, this may be any number. For example, like 1, 2, etc. to n. Each having focal length f1, f2, f3. Then the combined focal length f equivalent is equal to 1 by f1 plus 1 by f2 plus etc. to 1 by fn. So this is the combined focal length. Combined focal length. Combined focal length. Next one, power. If focal length, if f is in meter, f is in meter, if it is given in meter, centimeter, you have to convert it to meter. If f is in meter, power p is equal to 1 by f. Power p is equal to 1 by f. Unit of power. Unit of p is diopter. Diopter. Unit of p is diopter. Combined power. Combined power, equivalent power. PE is equal to P1 plus P2 plus etc. How many numbers are given? That many numbers has to add. If 2 will be there means P equal to P1 plus P2. The next point. For converging lens. For converging lens means which lens? Convex lens. For convex lens, f is positive, p is equal to 1 by f is also positive. Next, for diverging lens, or concave lens, for concave lens, f is negative, p is equal to 1 by f is negative. Both are negative. F is negative, p is negative for a converging lens. Then the third point. For a converging mirror, which mirror it is? Concave mirror. Good. Concave mirror. F is negative. Okay. Mirror the case. For mirror, below right, for mirror, P is equal to minus 1 by F. Remember this, important. Lens opposite. 1 by B minus 1 by U. There 1 by B plus 1 by U. Their magnification minus B by U. Here magnification is B by U. Their power minus 1 by F. Mirror density 1 by F plus. So if F is negative, P is what? P is also equal to minus 1 by F. F is also negative. So power is equal to what? Power is positive. Power is positive. Okay. F negative and power positive. So F is combined. F is negative. So P equal to minus 1 by F is positive. Next one. For diverging mirror. Diverging mirror means which mirror? Convex mirror. Convex mirror, what happened? F positive, P is negative. Next heading, cutting of lenses. You may get this, you will see through questions this one. You can cut the lenses in two ways. Okay. If the lens is like this, you can cut the lens two pieces like this, or you can cut the lens like this also. Depends how it is connected. If this focal length is capital, okay, let me make it as, if this focal length is capital F, then this piece will have F, this piece will have F. So I can write it as capital F is equal to 1 by F plus 1 by F. Capital F equal to 2 by F. One by F equivalent power. So I can say small f is this one capital. So F is equal to 2F. F is equal to 2F, which means if a focal length which is given will be here. Suppose this is equal to 10 centimeter for a biconvex lens, and you cut and you made it as a plano-convex lenses of two pieces. Then each piece will have a double the focal length. 20 centimeter here will come, 20 centimeters here will come. Very important. Okay, depends upon how they are cutting. If they are cutting like this one, F is equal to double the focal length. But if it is cutting in horizontal, focal length will remain unchanged. This focal length is equal to 10 centimeter and this focal length is also equal to 10 centimeter. Important. You will see in questions. Through questions it will come, but may not be there as such. This one. This point understood through questions we will come to see. Next heading, silvering off one side of the lens. Silvering off one side of the lens. Silvering of one side. What is called as silvering? Silvering of lens or one side of the lens. For example, listen here the idea behind this one. You can see some questions like this. Or you may have already seen, I don't know. Okay, so this is equal to you have a convex lens plus you have a what mirror? Concave. Like this you have to consider. Okay. So there are three focus will be here. For example, the combined will have one focal length. Okay. This structure will have an effective focal length, this one. And each of will have its own radius of curvature, its own focus. For the first surface, the focus is for lens. This is a lens focus. First radius of curvature, first focus. And this is another radius of curvature with another focus. But as it is a thin lens, this gap is very small, so both are almost equal. And this is the focal length of the mirror. Okay. So question will be coming something like this one. Then 1 by f equivalent is equal to 1 by combined focal length is equal to how I can write it as 1 by fl. Correct. 1 by focal length of the lens plus 1 by focal length of the lens plus 1 by focal length of the mirror. Okay, but here one thing is important. What is that? What is like this? Okay, first draw the diagram, then we'll explain. Everything will be right. First silvering of it, just to draw this diagram. Do not write the equations. I have to say something there, but just only draw this one. Do not write the formula, only draw the line. I have to say something there. Okay. You have just drawn the diagram and written this one, then right? Right. Silvering off one side of the lens give rise to mirror structure. Silvering off one side of the mirror give rise to. Silvering off one side of the mirror give rise to. Silvering off one side of the mirror give, one side of the lens give rise to mirror. One side of the lens give rise to mirror. Okay, then listen to the board again before going to the formula. Suppose if I placed one object will be here. What will happen? Instant ray will go here. Ray is moving from rarer medium to denser medium, so we have a normal ray. So ray will be bending towards the normal. Correct. Then ray will undergo what will be here? Refraction happen here. This will undergo reflection. So this ray will come reflection. So I can say this is a step number 1. This is what is happening will be here actually. Refraction. This is because of what? Because of lens. Number 2 is happening will be here. Number 2 is what? Reflection. So what is coming to picture for reflections? Mirror. Mirror will be there. Again you are coming here. Now the ray is moving from denser to rarer medium. It is not bending towards the normal. It is bending away from the normal. So you will get an image here. This is what is happening. Okay. So again this is the third step. Third process happening. So you have 3 steps will be here. Here what is coming to picture? The third one is same as the first one. Third one is same as the first one. So so if you split this into this diagram, so here first when a ray is moving, what is happening? Refraction. Then ray is hitting will be here, reflection. Yeah? Then a ray is returning back. ray is represented as a fraction. Okay, so 2 times lens is playing a role will be here, but only 1 time mirror is playing the role. Okay, so for a convex lens, it is positive. Focal length, combined focal length is positive. Okay, so for the first path, so this is equivalent to the first path, 1 by f. Okay, and this second one is equivalent to this one, mirror, and the third one is equivalent to this one. Okay, but the incident ray is always like this. Incident ray is moving in a forward directions, always. Okay, now if you consider for the first surface, if you consider, incident ray is from left to right, case number 1, left. So FL is a focal length of this piece, or the focal length of the lens. I can say focal length of the lens. So it is positive. As in another way, I know it's a convex lens, it is positive. But for a mirror, if you take, this is a mirror, second one is a mirror. So if you take a mirror, you will take the focus half of the radius of curvature towards left side, and that is opposite to the direction of incident ray. So instead of coming plus will be here, a minus will be here. Okay, third one your coming will be here. So for the first surface I have taken it is positive, and for third surface means this one. Okay, third surface, this is the incident ray, and this is a surface. Surface means this surface is acting. So here, this is the direction of second focus you are taking. So second focus is the same direction of incident ray. So it is also positive. So your formula is 1 by FL plus 1 by FL plus 1 by minus FL. By combining this, we can written as 1 by FE equal to 2 by FL minus 1 by FL. That's what you are getting a minus in the formula. Because of this process, these 3 processes will be there. Okay, previously we have done last 2 classes like 3 steps will be here. Here also 3 steps will be there. Okay, understood how this formula is came, how the minus is came. So you understood, now you can write your own understanded way. That's what, it's very difficult to explain, right? Sentence. So whatever you understood, you just explain. You can write mark 1 refraction, second 1 reflection, third one is same as the first one. You can write like take your findings and then complete the notes. What you understood from this one. Exactly the same thing. 1, 2, 3 steps. So the mirror is negative because here is positive. So again, here it is negative against the direction of incident ray. But here for this surface, it is the same direction of incident ray, so that you are getting second FL positive. With this surface correctly, but with this surface, this is just like a 2 piece. This surface difference illa. This is called as thin lens. While we are drawing like this. Actually, in reality, it's like this. I am thinner, and the surface of the discriminant part of here. Thin lenses. Thin lenses specs in the mirror 100 times smaller. So you can imagine how much it is size. That's thin lens. But specs use the lens size very thin. That's 100 slice. That's very thin lens size. Once you complete it, tell me. Why smaller, thinner? Plus 2 chemistry are using a test tube. That's thinner. Test tube is very thinner, right? But it's hard, thinner, but then. So, 3 steps in the process already formula 3 terms for a particular reason. one very interesting question is asked this year. I will tell you the question, we will do it later. For JEE main examinations. Advanced this year, it's already completed for IIT. The question is like this. This is a water body. Okay, this is a water body, and they have given a diagram like this also. So water will be there, right? One water will be here, and this is a kind of a bucket, and it is filled with water. Okay, and what the goal means? Here a bird will be there, and a bird, and okay, here it is something silver. A bird is want to catch a fish, and fish is there on the bottom of here. On the bottom will be here, where the bird sees the image. That question. Where the bird sees the image. Because you know, the concept. What? Why? Because means first Eve structure. Eve structure is called what? Concave lens. So concave lens. Then Eve upper part convex lens. Then lower part plain mirror. Okay. Appa plain mirror. This is a combination. This is a combination and not a solid. Theoretical questions are 5 mark. So there are some hard work will be there. Okay. So then we'll see later. Likewise, they will ask, and we have to find out the combined focal length using this formula. So you know this object distance. You can find out the image. That's the logic. This is the focus length. This is the focal length. This is the focal length positive. This is the focal length negative. Plane mirror the focal length radius of curvature infinity. Correct? Infinity. So no focus. There will focus. This is the focus. Now lens in the formula lens 1 by FL plus 1 by FL. Mirror mirror the plane mirror now this is 1 by FL plus 1 by FL. One FL positive, one FL negative. Combined focal length. This bird is position some 60 centimeters. Then you can apply which formula? Lens formula 1 by V minus 1 by U equal to 1 by U. U go to F with the V conduction. Okay, that's one. Well, then idea can understand. So write down one question. Find the position of final image formed by the system. Find the position of the final image formed by the system shown in the figure. Find the position of the final image shown in the figure. F lens equal to 15 centimeter. Object is at a distance of 20 centimeter. Find the position of image. Object is at a distance of 20 centimeter. Lens in the focal length of 15 centimeters is given. So just substitute the value 1 by F equal to 1 by FL plus 1 by FM plus 1 by FL. Here how many steps will be there? Not 2, 3. First enter of the refraction, then reflection, then refraction. So 3 steps. So always if 3 steps will be the formula will have 3 terms. First enter of the refraction, reflection, refraction. So you have to take directly 1 by F equivalent is equal to, you know the formula 1 by FL, first refraction, second one mirror 1 by FM, but I know it is a plano concave mirror. Plano concave concave mirror, the focal length is how much? Focus is, radius is infinity. So focus is also infinity. Upon this mirror role you can put the plus or minus. Second one, again refraction. Again because of lens. 1 by FL. I'm going to step analyze here. First refraction. So 1 by FL. Second mirror. This is plane mirror. Plane mirror radius is infinity. So focus is also infinity. Up is 0. Then ray hit reflect it become the third refraction. Third refraction is lens. I will ask one question. The overall, this is a lens. I know this is a combination of lens with the mirror, but overall effect, it is a mirror or lens? No. Overall, it is a mirror, right? Finally, you see refraction, reflection, refraction. Your ray is coming back to the same medium. Your ray is coming back to the same medium means what is the overall effect? Reflection. So overall, the structure is a mirror, not a lens. Okay. So overall, to find out, now you got Fe. Okay. How to find out Fe? Tell me. 1 by FL, 1 by 15. Plus 0 plus 1 by 15 you got. So Fe equal to what? Fe is equal to 15 divided by 2 you got. Okay. Now using this Fe and using the image position you have to find out using the object position you have to find out the image position. To find out the image position, which formula you use? Mirror formula, lens formula? Mirror formula, because overall effect is a mirror. Overall is a reflection. Refraction is overall it is reflections. Not a mirror formula you have to use to find out the image position. One more thing. I told overall, just listen one moment. I'll explain. Overall, it is a concave mirror or convex mirror. Concave or convex. Okay. Just a few more. Before answering, just listen here. Few more things has to tell. Else you will get confused. Overall, it's a concave mirror or convex mirror. It's a concave mirror. It's not a convex mirror. Why? Because the rays are entering. Okay, we can just draw the diagram. It's coming inside. So what will happen? It is bending towards the normal. So it's not going like this. It is bending towards the normal. So it is bending towards the normal. Then what will happen? This is a plane mirror. So what will happen? Reflections. So angle of incident is equal to angle of reflection. Is that in a normal, right? So angle of incident, angle of reflection. Then here also I will draw the next normal. I have to draw the next normal. Then ray is going from denser medium to rarer medium. So what will happen? Ray is bending towards normal or away from the normal? Away from the normal. So which means the ray is coming somewhere here, for example. Away from the normal. So I will get an image will be here. This is what is happening. Okay. So the overall it is a convergent. So if you do, if you see a converging mirror, parallel rays meeting here, and always it is converging. Always it is pointing to a single point. So always it is act as a converging mirror. Overall it is a concave mirror. Or converging mirror, or it's a concave mirror. If for a concave mirror, focal length is what? Focal length is negative. Here overall it is negative means overall then is called what? Fe. Fe is negative. So whatever the value you have to get, it will be a negative value. So once you got the solution set, you have to say this is the overall focal length. Overall focal length. And overall it is what? It is a concave mirror. Overall it is a concave mirror. So FE equal to minus 15 by 2. Then overall it's a concave mirror. So mirror formula. So mirror formula is to apply. What is the mirror formula? 1 by V plus 1 by U equal to 1 by F. Then object is at a distance. Here U in the value minus 20. F in the value minus 15 by 2. Either V continue. This is lens in the focal length. This is lens in the focal length. This is mirror in the focal length. Individual. What's answers coming?
5 point.
5 point? Minus 12. Next question, right? Find the position of the final image. Find the position of the final image. Find the position of the final image formed by the system. Find the position of the final image formed by the system. Here, the question is like this. Let R equal to how much is the value? 10 centimeter. Focal length of lens equal to 10 centimeters. And object is here. Distance of 10 centimeters. Then this is a lens n equal to 3 pi, and this is an air medium. So mirror effect is there, right? Combined focal length has to find out. Tell me what is a combined focal length? 1 by FL plus another 1 by FE equal to first reflection. So 1 by FM plus 1 by FL. 1 by FL. It is positive. So 1 by 10. Focus positive. Mirror, it's what type of mirror? Concave mirror. So FM is negative. So 1 by FM, radius of -5. Correct. Other one is 1 by FL. So 1 divided by 10. So 2 by 5. It become 1 by 5. So 1 by FT equal to 0. FT equal to infinity. Focus is infinity. Okay? Correct? 1 by FT is equal to 0. So focus is infinity. Then it's overall it's what type of mirror? Okay. Specifically, FE is at minus infinity because it overall it's a concave mirror. Overall, it is a concave mirror. Overall, it is a concave mirror. So we are applying the mirror formula. 1 by F equal to 1 by V plus 1 by U. 1 by FE, 1 by minus infinity equal to 1 by V plus 1 by U minus 10. So this is 0 minus 1 by V equal to minus 1 by 10. So V equal to 10 centimeters.